everybody. Today we're going to be finishing the notes on section 2 of chapter 3, Newton's laws of motion. Now, we've already looked at the first law, the law of inertia, that says as long as the net force is 0, everything stays the same. The second one, the second law, says that if the net force is not 0, if all the forces do not balance out, whatever's left is the net force, and it will make the mass accelerate. We've even practiced some problems doing that. Today we're going to look at Newton's third law of motion, okay? So let's write that down. The third law of motion. Now, you actually have probably heard this one before because you hear it repeated every once in a while in life, on TV shows, in movies even I've heard it. So think about this for a second. I'm sure you've heard it. It says, for every action force, there is an equal, and I'm going to underline the word equal. Hang on just a minute. I can't get my pen under here. There we go. And oppositely directed reaction force. Okay? You've probably just heard it as for every action there's an equal and opposite reaction. All right? But the last two things there are actually quite important. For a force to be a reaction force to an action force, there must be two requirements. They have to be equal and they have to be oppositely directed. All right? In other words, they're a pair. So, if you have an action force, there's always going to be a reaction force, and that reaction force will be equal in numerical value, and it will be oppositely directed, okay? So look at this right here. Let's talk about these situations. All right, here is a person who's stepping off of a skateboard. So they're pushing back on the skateboard. The skateboard, in turn, will push forward on the person's foot. And these two forces are action-reaction forces. Doesn't matter if you look at the person who's pushing back and as the action or the reaction. It doesn't matter which one you consider the action or reaction. You just have to remember they're going to be equal in numerical value and opposite in direction. Okay? Now, what will be the result of this action-reaction pair? All right, well, this force acts on the person, so the person goes forward. The force from the person acts on the skateboard, so the skateboard will move backwards. Each object will move in the direction of the force exerted on it, okay? So, let's look at the next one. You may have seen something like this take place at the roller skating rink or the ice skating rink. It's just that here they're on skateboards. But let's suppose you stand with your friend and you put your hands together and she just stands there. She doesn't try to do anything and you push on her hands. So you're going to exert a force on her. And of course, the result of that force is that she'll roll to the left. But when you exert your force, her body, without her even trying, her hands are going to exert an equal and oppositely directed force back on you. So what will you do? Well, you'll roll to the right, won't you? Okay, now let's look at this. Here's a rocket. Here's how rockets are propelled forward. The engine of a rocket takes the fuel and burns it, and it gets expelled out the end. Well, the force of the hot gas being expelled out the end has a reaction force of pushing the rocket forward. How about that? Okay, the two forces are equal in numerical value. They're just opposite in direction. As long as the rocket engine is firing and expelling the flame, the gas, then the rocket will accelerate forward. If you turn off the engine, whatever speed the rocket will have at that point, it'll maintain until you turn on the rocket engine again, okay? So, action-reaction pair. The gas is expelled and accelerates that way. The rocket moves that way. Pretty cool. Equal and opposite pairs, equal and opposite reactions to motion. All right, look at this one. Suppose you're just standing there. All right, if you're standing there, gravity from the earth is pulling down on you right here, okay? So the gravity of the earth is pulling down on you. But now remember, you're a mass too. You have gravity. So when the earth pulls down on you, you're going to pull up on the earth. And guess what, guys? You're going to pull up on the earth just as hard as the earth pulls down on you. Remember Newton's remember Newton's universal law? The gravity depends on the product of both masses. So when you pull up on the earth and the earth pulls down on you, the two forces are equal and oppositely directed. Okay? Now, as you can see, we're looking at a lot of forces here. But when we have a problem, how do we know which of these forces we want to use? Well, it depends on what the focus object is. When we're looking at a problem, we're typically looking at only one of the objects. Like it could be the skateboard itself, or it could be the man who's pushing, or the rocket rather than the expended fuel. All right? Could be the man, not the earth. Whatever the focused object is, that's the one you want to look for the forces. You want to see what forces are acting on that particular object. Now, we don't care what that object may be exerting on other objects. We only care what force is acting on the object in question. Okay? Let's look at an example where there's a lot of forces and we have to think. Here's a lady pushing a lawnmower. So we want to know, what are the forces involved here? Okay? Well, let's suppose that the lady is the focus object, and let's see what the forces are. Now, we know that she's pushing on the lawnmower, but that's acting on the lawnmower, not her. But from Newton's third law, we know if she's pushing on the lawnmower is pushing back on her with a reaction force. So that is one of the forces acting on her, so we write that down. Which forces is acting on the woman? Okay, so that reaction force from the lawnmower. What else is acting on her? Well, gravity from the earth is pulling her down. She's pulling up on the earth, but we don't care about what she's doing to the earth. We only care about what the earth is doing to her, don't we? Okay, so her gravity from the earth. What else is acting on her? Oh, well, she's pushing down on the ground. The ground is pushing back up. So the force from the ground. Okay, so let's put that here. Force from the ground, pushing up on her. All right, what else? Oh, there's one more thing. There's friction acting on her. When she pushes back with her foot, friction between her foot and the ground pushes forward to propel her forward. Okay, I know that sounds weird. The friction actually points forward, but that keeps her foot from slipping back. So friction is also acting on her. There we go. Those are the forces. We don't care if she's pushing back on the ground. That's acting on the ground. All we care about is the forward friction that helps her move forward, keeps her foot from slipping. So these are the forces acting on her. And if we were looking at her motion, those are the ones we would use to find the net force. Now let's look at the lawnmower. And I'm going to use a different color now. I'm going to use red. Let's look at the forces acting on the lawnmower. Not what the lawnmower could be doing to other things, but what is being done to the lawnmower. First, we know the lady is pushing the lawnmower, like this. So there's the applied force from the lady. So we write that down. That's acting on the lawnmower. We also know that the earth is pulling down on the lawnmower and the lawnmower is pulling up on the earth. Well, we don't care that the lawnmower is pulling up on the earth. The earth is not our problem. The problem is the lawnmower. So we simply have gravity pulling down on the lawnmower. We also know that the ground is pushing up on the lawnmower, just like it was here. So we have a force from the ground pushing up on the lawnmower. Doesn't matter that the lawnmower is pushing on the ground. We don't care what happens to the ground, only the lawnmower. All right? So we've got the gravity of the lawnmower and we've got the force from the ground. Okay? Now, what else? Well, the lawnmower is moving forward and there's friction between the wheels and the ground. And that points opposite the motion when you're rolling. So there's the friction. And we add that. The friction is acting on the lawnmower, okay? So those are the forces acting on the lawnmower. We don't care about anything else if that's our focus object. I hope you understand now how we're doing this and that it makes sense. So I want you to think about it, and then you're going to be doing a discussion where you watch some videos. Think about what we've said, okay? I'll see you soon. Bye-bye.